Are you kidding? I'm about to make a video with more examples than just the magnets, but it would be daft. You don't think that tree, the aspects of that tree have been described with quantum mechanics, namely its biomechanical aspects, and they're still being described. As a matter of fact, the leaves of that tree look in the last couple of years very much like they collect solar energy exploiting quantum mechanical phenomena. You don't think it's worth explaining that? It would be daft. Yeah, you use the tools at the scope, but the whole point of the unification that goes on in physics is that ultimately, even if it's an okay approximation to use something else, the real explanation is the one that can explain everything, right? Now, yeah, you can use Newtonian mathematics and ideas of hardness when there really isn't hardness because you don't even touch that tree. What you're feeling is the magnetic pushback of getting a magnet really, really close together. Yeah, that's the kind of thing that is, right? So, yeah, you can use hardness and texture and all these lovely human and physical things, and they can all be explained statistically and with quantum mechanics, but you can use these other ones instead. And why would you do that? Is it because reality really is that way at the scale that you're thinking at? No, it's because your mind is limited and you're trying to save yourself some work. You could do all the solutions with quantum mechanics, but the daft part of doing that is that you don't really need to care about where every molecule is. But guess what? Quantum mechanics doesn't say care about that. It says do the statistics. And when you use Newtonian mechanics, you're doing the statistics and ignoring the part that defies those basic statistics. And it's such a small part that that's fine. But it doesn't mean it doesn't exist, but I'll get into that in the other video. But come on, conference report. Think about it. The fundamental physics is what does explain everything else, and you can't tell me there's a lot of things about that tree that are explained quantum mechanically. Because just remember, all the chemical reactions and how they work are all explained quantum mechanically. That is kind of where it came from chemistry, or particle physics, so-called, where you get chemistry really broken down, atomic chemistry, where we're trying to see what the smallest bits are, if there's a smallest bit. It's an ancient argument over if there's a smallest bit or not. They've been looking and looking, finding out all kinds of weird physics about this stuff, and it does apply to us. Of course, you use another idea. It's like, well, you'll see in this other video, but you can analyze art with quantum physics in terms of the physical structure. You can't really analyze art interpretation until you figure out how the brain works. Well, I mean, see, that's not fair. Of course, you can analyze the brain with quantum mechanics, which includes all of the Newtonian mechanics and all of the law of averages that look like what you guys want to call and think of as determinism. You can do that, and we do that, but we have missing parts. We don't know why it's conscious, okay? But whatever makes it conscious is going to have to do with the physics that applies, the lowest, most fundamental physics. And we look for more fundamental physics because the high-level physics doesn't seem to explain it. But anyway, okay. Cheers.